My name is Mariesse van Sluisveld, and it's nice to virtually meet you all like this. And I'm happy to be here, and I'm happy to be able to tell you something about the use of large-scale computer models in transition studies. And I have become aware of the fact that you've heard a thing or two already from earlier speakers about the type of model that I'm going to talk about and how they score on providing a narrative of change. And I'm particularly going to talk about integrated assessment models, which are climate policy models used to explore the changes in, as they say, the energy, economic, and environmental systems under a specific constraint. And for this type of model, it's usually a climate policy objective that is the constraint. And today I hope to introduce you to the field of integrated assessment models and touch upon the various things that are connected to it. And I will try to make it as tangible as possible, but do ask questions at the end if you're still not super clear on, if you still have questions about it. So who is introducing you to this field? Well, that's me, Mariesse, and I'm a researcher who started her work at Utrecht University in the Netherlands. And although I moved through various research institutes over time, there was always one common denominator, and that's I've always used and analyzed integrated assessment models. And as a result, I have a very broad understanding of global, regional, and sectoral or subsectoral energy transitions. And my doctoral thesis was about evaluating these models and contrasting or testing modeling results with alternative methods that could say something about future change. So the first question you might ask yourself is, why do we need integrated assessment models? And as many of you know, climate change is a very complex problem that affects every aspect in our natural and human environment. And as a result, it has been studied from a variety of angles, such as you could see on the screen just now, like from the natural sciences to the social sciences, from political science to international law, etc., etc. And we have come at a point that analyzing climate change is now so complex and so intertwined that we cannot handle it any longer with just one single brain. In fact, we need external tools that provide some mental support to structure and consistently help us think about the consequences of our actions. And which, in the words of one of the founding fathers of the field at his 2018 Nobel Prize acceptance speech, Bill Nordhaus, is integrated assessment modeling. And what is integrated assessment modeling? Well, integrated assessment modeling is, in essence, a compilation of mathematical formulas, which are drawn from all these variety of fields, but are selected in such a way that it describes various physical and economic phenomena. And if we put all these mathematical formulations back to back, it shapes a representation of how we think about the linear and nonlinear causal relationships between society, the Earth system, or the climate system. And by feeding the model with some starting values, for example, historical values on GDP, population, or energy demand, or technology growth, and you can start running the model. And eventually, after all the computations are done, the computer will spit out information on your control variables that you want to know more about. So for integrated assessment modeling, that's usually like impacts on land, climate, air, and we are particularly also interested in total CO2 emissions, because they can tell you something about the average temperature increase over time. And these integrated assessment models, as it covers climate change research, it's usually on a global scale. And there's a variety of models. The very simplified example that I'm giving here would classify more as in a very difficult long word, recursive dynamic partial equilibrium simulation model framework. And they have various resolutions. And yeah, well, as climate change and its impacts take place on a global scale, you want to capture the most relevant trends and insights that take place on a global scale. And meaning that you try to compartmentalize and generalize on the energy, economic, environmental axes that there are there, and try to find data and information on those elements. And this would be like an example specific to the image integrated assessment model. But most of the currently available integrated assessment models are more or less of a similar basic setup in this kind of setting, like a certain number of world regions, covering income quintiles. They're covering all the greenhouse gases. They represent the energy demand and energy supply sectors. They have a set of technologies that they represent, and also like more on the human system, for example, like they provide energy service and they try to analyze the impacts or effects of climate policy on those over time. And the philosophy of modeling is basically to reduce your subject of interest to its core elements, as to study if we understand how it works, but also if it behaves, how it behaves under different situations, and therefore looking for potential tipping points, therefore creating better understanding of the world around you. And to make a compilation of our current understanding of the world, an integrated assessment model draws from today's knowledge, or more accurately, yesterday's knowledge, that has been empirically documented, such as historical information or the known knowns, or the more tacit knowledge for which we have some confidence of accuracy, but no solid empirical data yet, such as expert knowledge or the known unknowns. So this is usually what is included in an integrated assessment model or any model. But there's also a whole lot of information that we don't really know anything about, or not know convincingly enough about to include them in the model. And we try to approach those elements through proxy, or in the integrated assessment modeling world, more like via storylines. And we use the model formulation and the storylines together to scope out the so-called solution space, or the possible direction of change that could possibly occur over time, according to the science and the boundaries set by the model. And as a result, and also in the words of Donella Meadows, global integrated assessment modeling is a wonderful expression of how some people in the world see the world. And I would like to add here of the world as we know today. And the field of integrated assessment modeling started somewhere in the 70s. I guess with the most famous publication is the Limits to Growth study, a report. It's a key example here to be mentioned. And since its inception, integrated assessment models have acquired an established position in the global science policy interface, having contributed to all the, for example, the IPCC assessment reports, special reports, and also the annual UN emission gap reports. And with growing importance of the field in these important endeavors for the United Nations, or perhaps a growing disagreement of scientists in how one should represent future change, and also a growing urgency to combat climate change in general, it has resulted in a boom of competing models and scenario studies. With the last one compiling a set of about 1,200 scenarios that could be studied. And these are just the scenario studies that have been submitted to an official portal, but there is also a whole lot of scenarios that have not been submitted. So the pool of information is quite large. And when I'm talking about integrated assessment models, I usually refer to a specific model family of which about 20 groups exist today that are frequently supplying knowledge of their view of the future in this regard. And several usual suspects who have been around for some time and lately also, so these are over here, and then there's also lately some new entrants who have joined. They're all sort of like spread out over the map like this. And I'm not showing every one of them, but especially the new entrants, I'm not super aware of them, but they're probably a result of more open source modeling, and which allows other teams to more quickly jump in on the bandwagon and produce their own scenarios. And the overall message of integrated assessment models has been more or less the same in the last 10 years, give or take, generally telling us that if we assume that a continuous system, so with one without climate policies, if a continuous system can be extrapolated into the future, or we keep going on as we used to, this result in a global average temperature increase of about 4 to 6 degrees Celsius. And this is more or less sort of like the depiction of those 1,000 scenarios from the IPCC fifth assessment report. It looks more or less like this. But the beauty of integrated assessment models is that they can provide a controlled environment that we can test under different considerations. Or in other words, we can create discontinued systems, either through setting policy objectives, a certain constraint, or via adding other constraints as we please. So, for example, we can set the policy target. And in the 5th assessment report, this was very likely a 2-degree temperature increase limit policy objective to see how the global system adjusts over time. And by setting further constraints, we can look for the critical elements that allow the model to comply with your main objective. So we want to meet the 2-degree limit of temperature increase. And then we can just play around with the model parameters to see how the model adjusts itself to that new situation. For example, we can block nuclear energy to be adopted and then look at what happens in all these models that run these scenarios. Or we can limit bioenergy use, or we can take out, for example, carbon capture and storage. And in this particular example, we therefore find that restricting your choice of allowable energy technologies lead to, well, less models thinking it is an economical idea. And some even think it might be an infeasible idea to remove that option of the portfolio of measures. And those that do think it's still possible, they all tell you that it comes at a higher cost. And in general, it doesn't really matter how you configure the model, because in general, the message in integrated assessment modeling studies is that either way, you have to remove fossil fuels, expand clean technology, expand carbon capture and storage capacity, do it as quickly as possible, achieve negative emissions to balance out our positive emissions that are still on the balance. And as the United Nations emission gap report already reports for the last 10 years, we need to do more than we currently think we need to do. But with increasing scientific authority in this field, it also leads to increased scrutiny of the results, leading often to criticism on what models have included. For example, raising claim that models lead to tunnel visions as a result of applying a very specific analytical lens that looks at only like technologies and economics as the leading drivers of change. And as a result, it favors technology choices that are made later in the century, as economics become more favorable over more early on action, leading to claims like we're very optimistic about what we can do in the future, or we are banking our whole hope on geoengineering, and we still think it's feasible, but that's a big question mark. Simultaneously, there is also criticism on what models do not have included in their configuration. And for example, as I said, most integrated assessment models focus on technologies and economics as the main drivers, but there's also a full spectrum of solution strategies that you could think of that are not economic or technological, because they are not included because the models have only a limited representation of socio-technical, socio-material, or socio-political elements. There is a trend of research looking into lifestyle change, but that's something that is a little bit difficult to fit into the model, but they're trying. So to some degree, we can appreciate the feedback that we receive from the policy community or the general public and academia, as it has led to a diversified portfolio of scenarios to be explored and also to more refined models. It helped us shape research agendas and new research projects. As I said, lifestyle change is one. Or social actor behavior. And it helped identify areas that need improvement. To look at it from a more abstract perspective, it's like most of this criticism is rooted in how knowledge is generated and represented in these modeling frameworks. And as it is mostly about keeping it simple and comprehensible, yeah, it technically means that you have to conflate various processes to its core, leading to a lot of like embedded uncertainties that you can talk about or agree or disagree with. Knowing or being transparent about how sensitive or how robust your model is to your modeling choices is therefore like an endless discussion about the credibility of the models. However, part of the criticism is also aiming at the saliency of the models, or in other words, how well they are able to address all relevant concerns relating to long-term transitions. And this is the difficult part, as there are many elements that are not covered in the integrated assessment model, or they are simply hard to generalize or translate into qualitative terms. But luckily, there are many other methods to map out a solution space that could supplement the modeling work. I'm now here to elaborate on the modeling part of the portfolio of methods, which is specifically focused on structuring evidence-based quantitative material. But other methods exist as well, which try to tap into more tacit or qualitative information and attempt to theorize on it. But also these methods combat limitations and or biases, and no golden standard exists on how to integrate all that knowledge into a single body, meaning that there will probably be no consensus anytime soon about how global transitions should best evolve over time. And lastly, one thing that also is very important with integrated assessment models is that you can have a very credible or salient modeling study, but then also legitimacy and social authority come into play, as it is about ensuring that legitimacy is about ensuring that a broad range of stakeholders or actors feel represented in your work. But it's also being aware of how everything can be very politicized. And it's really important. It's very important who is reading your work and who is publishing the work. And yeah, I'm not really the expert on this, but I just wanted to mention it here and provide a very recent example on social authority, which is the Net Zero by 2050 study by the International Energy Agency, which is an organization that enjoys a lot of social authority. It has been acknowledged that the work does not venture off into uncharted territories of the existing science base, yet the fact that the IEA is underscoring several conclusions, it may be a tad bit more effective than, for example, another IPCC report. So it's not, it's an interesting new report, but might have a bigger impact in the world than maybe a publication that I would write with my model. So to conclude, modeling has been a very effective method to study long-term transitions, and it had a lot of successes over time. But we should always keep in mind that models are simplified representations of our current understanding, and they support our thinking on the causal relationships between society and the natural environment, and not necessarily provide the exact values to benchmark climate policies too. So that's something to remember. And modelers in the field are also burdened by a never-ending quest to build the most credible, salient, and legitimate model that can answer all your policy questions to the best of their ability. And modelers are generally there, very eager to serve, eager to learn, and generally very motivated to do good to do good to the world. But yeah, that's it's a bit masochistic maybe. They just enjoy being criticized all the time and trying to go back and improve. But to remain relevant as a research discipline, there are still a lot of things that need to be done, particularly now that transition research is more focused on how the transitions should be implemented instead of do we need a transition, or where do we need to go in order to meet the climate target. And that's mostly about to improve the effectiveness of your knowledge. Linking knowledge to action is more about becoming more interactive or open to new ideas. And that's both on the actual modeling side, so opening up the models, being very transparent about your assumptions, as well as open to new ideas outside of the modeling world. So being able to create richer narratives through interaction with other disciplines or other stakeholders or actors in order to become more holistic. And this kind of trend that proves absolutely necessary for research that includes, for example, sustainable development goals, the trade-offs, the synergies of sustainable development goals, circular economy work, as well as the policy movements that focus now on net zero emissions by 2050. It's like you need all those perspectives to make a better study on what needs to be done in order to achieve all those goals or objectives. And I think that's more or less what I wanted to say about integrated assessment models. And thank you for your attention, I would say. And if there's questions, I'm happy to take them right now.